Solutions play an important part in our lives, so measuring the concentration is important. Let's discuss the units to measure the concentrations. So then, solutions. Solutions are homogeneous mixture of two or more components. Now the components can be solid in solid, example alloy. A 22 karat gold contains copper in gold. It can be solid in liquid, example salt in water, even sugar in water, or liquid in liquid, example alcohol in water, or gas in gas, example air. Air contains carbon dioxide, oxygen, water vapor, inert gases, and nitrogen. Now, a solution has two parts. A solute, the component present in small amount. Example, in a 22 karat gold, copper is the solute. There can be more than one solute. Example, if you take an aqueous solution containing salt as well as sugar, then salt and sugar are the solute. The second part is the solvent, which is the component present in large amount. Example, if you take air, nitrogen is present in a large amount, so nitrogen is the solvent. Remember, there can be only one solvent. Let's pass on to the units to measure concentration. Mass percentage. It is the mass of solute in 100 grams of solution. Representation is mass percentage. Example, 25% by mass of aqueous ethanol means it has 25 grams of ethanol in 100 grams of solution. That is, there is 75 grams of water. The next unit is volume percentage. It is the volume of solute in 100 volumes of solution. Now the volume can be measured in milliliter or liter. Its representation is volume percentage. Example, 25% by volume of aqueous ethanol means that's 25 ml of ethanol in 100 ml of solution. That is, there will be 75 ml of water. The next unit is parts per million. Representation is ppm. This unit is used when the amount of solute is very small. It is a parts by weight or volume of solute in million parts by weight or volume of solution. This unit is used for measuring the pollutants in air because the amount of pollutants present in air is very small. Next four units are the commonly used units. Normality, represented as capital N. It is the number of gram equivalents of solute in 1 liter of solution. Now, gram equivalent is calculated by dividing weight of the solute by the equivalent weight. Now, how do you calculate equivalent weight? For example, for a base, you divide the molecular weight of the base by the number of hydroxyl groups. Example, in NaOH, you divide the molecular weight of NaOH by 1 because it has got one OH group. If it was an acid, the equivalent weight of the acid is calculated by dividing the molecular weight of acid by the number of hydrogen ions. Example, in sulfuric acid, there are 2 H plus ions, so molecular weight of sulfuric acid is divided by 2. Next important unit is molarity. Representation is capital M. It's the number of moles of solute in 1 liter of solution. Now, how do you calculate number of moles? It's the weight of solute divided by its molecular weight. Example, 2 molar sodium chloride means there are 2 moles of sodium chloride in 1 liter of solution. Another important unit is molality. It's represented as small m. Is the number of moles of solute in 1 kilogram of solvent. Example, a 2 molal KCl means there are 2 moles of potassium chloride in 1000 grams of solvent. Now remember, a 1 molar solution is more diluted than a 1 molar solution. This is because one molar solution has 1000 grams of solvent. The most important unit is mole fraction, represented as psi. It is a ratio of the number of moles of any one component to the total number of moles of all components in solution. Example, in an aqueous solution of sodium chloride and KCl, the mole fraction of sodium chloride will be the ratio of the number of moles of sodium chloride by the sum of the number of moles of sodium chloride, KCl and water. Remember, sum of mole fraction of all components in a solution is 1. Now, the most preferred units to express concentration is mass percentage, molality and mole fraction. This is because weight does not change with temperature while volume changes. Molality is independent of temperature as only weights are involved, while molarity is temperature dependent. So these are the units to measure concentration, which is used during titrations, experiments and problems in chemistry.